Thanks, Stephen, and thank you to everybody for joining us today. As Stephen said, my name is Dan Martland. This presentation is focusing on the new fast payment service and the testing challenges it will present to organisations joining FPS. The presentation will quickly look at where FPS fits within the infrastructure of most organisations, then start to look at the challenges which will need to be addressed as new members design their implementations of FPS. After that, we'll move on to look at the different types of testing that will need to be undertaken and the specific challenges that will need to be overcome. Faster payments is designed to speed up several types of transactions. The first set are called single immediate payments, or SIPs, and these are transfer requests that come from customers in real time, either via web systems or via telephone service, which could be automated or manned. The second set of transactions that FPS affects are back-office generated transactions for standing orders and forward-dated payments. There's no need to update direct debit systems, as these already provide fund transfer without incurring any float, which is one of the key aims of FPS. So telephony, web and back-office systems will all need to change to accommodate FPS. In addition, there is a new component that needs to be implemented. This is the FPS gateway, which handles sending and receiving messages to the central infrastructure, and thereby handles all the transactional elements of FPS for an organisation. There are several solutions now available in the marketplace, and these can be brought in and configured to an organisation's needs. Alternatively, at least one of the first wave members wrote their own gateway system from scratch. Let's look now in detail at the specific challenges that FPS provides in relation to system design and testing. Firstly, this is primarily an integration project, integrating your systems with the switch. As such, it is critical to understand the behaviour of the switch when deciding how your systems will interface with it, and this understanding needs to be both at a message level, i.e. which messages get sent and in what order, and at a message content level, that is, what elements make up each message and what format rules they must comply with. Now, as you would expect, there is extensive documentation describing the system. And this describes the positive behaviour of the system, that is, what happens when things go right, in a high level of detail. The negative behaviour of the system is more complex, as there are many points in the chain where things could possibly go wrong, resulting in multiple branches of failure behaviour. Because of this, the original documentation did not describe all the behaviour of the system under error conditions, and so first wave members had a steep learning curve. The system is now better understood, but this is still a very complex area, and the messages used to report errors are very flexible, meaning that you have to understand how to interpret them correctly. And remember that your systems will need to carry out this interpretation without human intervention and in tight timescales, so a robust solution is essential. Now, this next thing seems like an obvious thing to say, but it's definitely worth saying. The system must be designed for performance. In many systems, performance is just an afterthought tacked on at the end, but your FPS implementation must have performance criteria built in from the ground up, as speed of operation is one of the key aspects of the system, and there are tight SLAs in place relating to this. As we've already touched on, FPS can impact many of your existing systems. Because of this, you need to look at each involved system both individually and as part of the greater whole when determining how they should be modified to support FPS. In addition, some aspects of your business, which currently depend on a batch approach, will need to be fundamentally redesigned from the ground up. These two aspects of FPS probably represent the biggest challenge in deploying it successfully. Here are a couple of examples of the last item, the things that are highly likely to need some fundamental changes. Firstly, let's mention fraud checking. Most organisations currently do this as part of their batch processing, which allows them to look at groups of transactions and spot patterns of suspicious behaviour. FPS means that many more transactions will now happen in real time rather than being part of a batch, and so your anti-fraud systems need to be able to assess each transaction individually and decide whether or not it should be allowed to go ahead. Similarly, customer management is a process that relies heavily on batch windows to allow the time for decision making on whether or not to carry out transactions on behalf of customers. When banks have high-value customers, they will often allow them to draw against incoming funds before those funds have arrived, whilst they're still in the process of being transferred. In the new FPS world, all decisions on payments need to be made in real time, and also there's not the same notice of payments arriving, which gives visibility of incoming funds. Okay, let's move on to look at the testing challenges that FPS presents, firstly with functional testing. The first thing to bear in mind is that this needs to be carried out across all the systems which will be modified, including both real-time systems and batch ones, and each of these systems will need to be considered both individually and as part of the integrated solution. With the wide range of systems being affected, analysis becomes even more important than usual. Some of the systems you need to update and test may be legacy systems that have not been updated in some time, or systems developed using RAD techniques which may only have light documentation. Either way, test analysis is key to focusing the efforts of your test team on the business and system critical elements of the solution, giving you the most effective testing possible with your resource constraints. FPS is a solution that will cross boundaries of many subsystems, and as such it is important that behaviour is documented across all the systems and the FPS switch, giving end-to-end behaviour. Even if all your existing systems are described in perfect detail, this is new behaviour and key to the successful testing and deployment of FPS. Another key factor to keep in mind is that this is a computer-to-computer system, intended to work with no human intervention. Because of this, accuracy in the messages sent and their contents is paramount. A human can interpret a nearly correct message and take a best guess at what it means. A computer cannot, and will simply reject any less than perfect communications. Now, to help you with the testing, there is a simulator provided by the vendor Immediate Payments Limited. This is a tool called VersaTest, which is very powerful and allows you to simulate the behaviour of the switch and thereby test your own software. The tool is very flexible, and so learning how to use it effectively is a key challenge in deploying your solution, and proved to be a definite learning curve for the first wave of members, as the tool has been highly customised to support this project. Similarly, since there's a high chance of multiple rounds of testing, including both system testing and integration testing, it's definitely worth looking at using automating test tools to support the testing of the customer-facing systems, such as web and telephony. In concert with the VersaTest tool, this would allow for end-to-end automation of tests, potentially bringing significant time savings to the testing process. Now, when planning your functional tests, it is key that you include both positive and negative behaviour. You should also consider tests for the system in a modular way, looking at the outputs generated in isolation against the specification before switching to testing the full send and receive process. This will give you a quicker turnaround in testing the first parts of the system to be developed, and given that multiple elements of the system need to be in place before transactions can be produced for real, this approach will allow you to start testing much earlier and thereby reduce the cost for defects fixing overall. Once the foundations are in place, it will be possible to test against the simulator provided by IPL. This will allow you to test many end-to-end scenarios from the perspective of your systems. You'll be able to check that transactions are finalised properly after a positive response from the switch, and conversely that transactions are rolled back if the switch sends a negative response. It will also allow you to test the ability of your system to resend messages when timeouts occur between you and the switch, and check how it handles duplicate messages which can result from timeouts elsewhere in the network, causing the switch to reply more than once. Note that institutions are expected to undertake multiple rounds of testing with IPL after they have finished their internal testing and completed the self-certification tests successfully.